All right, today we're going to dive into one of the most complex industrial environments you can possibly imagine. We're talking about a massive chemical plant, and we're going to see how a new kind of artificial intelligence is stepping in to tame its inherent chaos. So let's just start with the big question, right up front. How do you actually run a system where, countless variables are changing every single second, and just one wrong move could literally cost millions? And this isn't some thought experiment. This is the day-to-day reality for a gas-to-liquids plant. And that brings us right to our main subject, what is basically a high-stakes chemical puzzle. We're talking about a facility that takes natural gas and turns it into super high-value liquid products, like diesel and specialty waxes. It's an absolute marvel of modern engineering, but it's also incredibly fragile. I just love this analogy. Really think about it for a second. Every single part of the plant, from the reactors to the pipes to the storage tanks, is like a finely tuned instrument. But here's the catch. Unlike an orchestra, there is no fixed sheet music. The music is being rewritten in real time by things like fluctuating gas quality, global market prices, even the weather.
And the sheer number of things that can go off the rails at any moment is just staggering. We're talking about the raw gas coming in changing its chemical makeup minute by minute. The reactor temperatures needing to be perfect, down to the degree. The catalysts that make the reactions happen getting old and less effective. And then you've got tanks filling up too fast. It is a constant, relentless battle against volatility from every single direction.
So how on earth have people been managing this chaos? Well, for decades, it's been a mix of spreadsheets, some slow simulations, and a whole lot of human intuition. Basically, they were running on spreadsheets and a good deal of hope.
And the consequences of doing things the old way? They're severe. Trying to run a billion-dollar plant with manual spreadsheets and data that's all over the place, it leads directly to lost production, unstable reactors, and incredibly costly disruptions. Every decision made with incomplete information is a huge gamble, and that is just a recipe for leaving millions and millions of dollars on the table.
But what if you could replace all that guesswork with something closer to certainty? Well, this is where the hero of our story comes in, a new approach called autonomous optimization.
So what is this thing really? An autonomous optimization model, or an AOM, is basically an AI brain for the entire plant. It's constantly taking in thousands of data points every second, predicting what's about to happen next, and then recommending the absolute perfect decision to get the most value, all while staying within every single safety and physical limit.
And it works in this continuous, closed loop. First, it senses everything that's happening in real time. Then, it uses that data to predict the future. Based on that prediction, it finds the single best path forward. That's the optimize step. And then, and this is probably the most important part, it learns from the outcome, so it gets smarter and more accurate with every single cycle.
Now, this isn't just one big AI trying to do everything. It's actually a team of specialized AIs all working together. So let's meet the 4 key players that were put to work at this plant.
First up, you've got the forecaster. Think of this one as the plant's early warning system. It's looking at the incoming natural gas and predicting things like, hey, in about 2 hours, the chemical makeup of this gas is going to change, and that's going to destabilize the main reactor unless we do something about it right now. It's seen problems way before any human possibly could.
Next, meet the orchestrator. Its entire job is to be the ultimate traffic cop for all the finished products flowing into storage tanks. It prevents these logistical traffic jams, making sure there's always enough space so the plant never ever has to slow down production just because a tank is full.
Then you've got the timekeeper. This one looks outside the plant walls at the ships, the trucks, the trains, and it calculates their true estimated time of arrival, factoring in things like weather and port traffic. This makes sure that a multi-million-dollar shipment of diesel is ready to go the very moment the vessel docks, not an hour before and certainly not an hour after.
And finally, the crisis manager. Because let's be real, something will inevitably go wrong. A reactor trips, a key pump fails. When that happens, this AOM instantly calculates the fastest and safest way to get back to normal operations, minimizing losses and protecting the equipment.
Okay, so a team of AIs sounds pretty cool in theory, right? But what does it actually mean for the bottom line? Well, the results, they are pretty staggering.
Get this. Just by intelligently managing where the products go, the plant saw a 40% reduction in production slowdowns caused by tanks being too full. That is a massive boost in output just from getting the logistics right.
And when things did go wrong, the crisis manager helped the team recover 35% faster.
In an industry where your downtime can cost millions of dollars a day, a number like that represents a huge financial win and a major safety improvement.
And you could see the impact right at the very core of the plant's operations. By stabilizing these key chemical processes, the syngas feed, the main reactors, the entire operation just became smoother, safer, and way more efficient. And it's simple. A more stable plant is a more profitable plant.
And here's where it all adds up. The biggest piece of the pie, 40%, came from simply making more of the most profitable products at the right time. But look at the other sources. Significant energy savings, extending the life of incredibly expensive catalysts, and a direct increase in overall production. It's not one single big win. It's creating value across the entire board.
So what we've just looked at, this isn't just a story about one chemical plant. It is really a glimpse into the future of all heavy industry.
This quote from the source material just nails the essence of this whole transformation. It's about moving away from human operators making thousands of isolated decisions under incredible pressure, to having a single, intelligent system that looks at the whole picture and optimizes the entire value chain. The role of the human, it shifts from being a controller to being the conductor.
And that kind of leaves us with a final, pretty provocative thought. We just saw an AI master a system with chemical, physical, and economic volatility that is almost beyond human comprehension. So if it can do this, what other complex systems in our world, from global supply chains to entire city power grids, are just waiting to be optimized? What really is beyond its reach?